going to show an example of getting a motor controller 55 motor programmed and spinning. Basically just need a battery, a brain, a motor controller 55, two leads to connect to the terminals on the back of the DC motor. And then it's helpful to have a zip tie to zip tie those leads to the body of the motor so that it has a strain relief so that you don't accidentally rip these off if someone tugs on these wires or if a robot part decides to tug on the wires. I'm going to be using this resource on the VEX knowledge base, kb.vex.com, and then connecting and configuring motor controller 55. And then I'm basically just going to step through how to configure this from scratch, and then also how to open up an example to push to your robot and have it spin, have the motor spin. So here on my table, I have laid out the micro USB cable that's plugged into my computer. I have a joystick plugged in right now, but I don't actually need a joystick. I'm just going to put that off to the side for now. I had it plugged in down here for the controller. And I have a motor controller 55 already wired up to the DC motor. A little red sticker on the shaft so that we can see it move if it does move. And currently there's no programs on my robot. So I'm going to navigate to codev5.vex.com. Just have a new project started here. It's a good idea to go ahead and name your project. Move motor. Save it to your computer. Once you've saved it, like named it and clicked save, you'll be able to see auto saving up here in the top. But I want to auto save until you've saved it to your local computer first. You can also choose which slot on your brain that you want to save it to. You can save up to 8 programs on your robot at a time and then pick which one you want to run directly from the robot brain or from the controller or from the computer here. I'm going to go ahead and connect to my brain. So I have my micro USB cable plugged in to my computer into my brain, and I have the power cable for my battery connected and my robot brain turned on. I can click connect, choose one of the COM ports that says VEX Robotics, and then the brain icon should turn green up here. It's a picture of the brain. So now I'm connected and my robot brain is up to date. Now I'm going to configure my devices. I'm not going to bother using a controller right now. I'm just going to use a motor controller 55 to get a motor to spin. So I'm going to choose motor port 1. It automatically names it MC55 for this device motor controller, and port 1 has a note. And then notice over here in my toolbox, some things in the motion tab have populated now that I configured that. Before I had no devices added in this device manager over here. These tools didn't exist in the toolbox, but as soon as I added them, they populated over here for me to use. And then we can just look at trying to keep it simple and just do spin motor at 8 volts. So when this is started, I want to spin the motor 8 volts in the forward direction. Try downloading that to my robot. I press play and can see my little sticker fell off my motor. The motor is spinning. I need a new red sticker. It's worn out. Hit stop. And then just to see what I did here, I could press the question mark for help, click on the block that I used, and I can see that the maximum range of a motor controller 55, if configured in the device manager as a motor controller 55, is -8 to +8 volts. So I could try putting a -8 in there and see if it spins in the other direction. There's an example down here. It says if you put it at 5 volts, you assume it's going to spin a little slower. You can do that for any block. Hit the question mark up in the top right, click the block, and then it will give you a definition of what that block does and an example of how you could use that block. You can also right-click the block and click block help, and it'll bring up the same thing as clicking that question mark. So let's see, let's play this one, see which direction it's spinning currently. If I look at this from the front, it's spinning to the right clockwise. Stop that program, put in -8 volts, and notice it's saving automatically. Download that to the robot and play. And because I set it to -8 volts and then forward, it looks like it's actually still rotating to the right clockwise. Try stopping that and try doing wiping this out and downloading it and pressing play. Okay, now we're getting reverse. So actually in my last program, it was setting this to 8 volts in the forward direction immediately, but then just sending a command of forward. So this first command was being read really quickly. Can't even see that it happened, and then it was running the one that was there before. What was it? Spin motor forward. That one's not even necessary. I could just use the voltage to see that. So now I'm going forward, -8 volts. You can see it's moving faster. I'm going to stop the program. Forward +8 volts. Download it. And now it's spinning clockwise at 8 volts. So that's the maximum speed. It's about a rotation per every second and a half or so. Stop the program. And then let's try doing reverse 8 volts. Download, play. And reverse does go counterclockwise. So I can change the direction either by giving it a negative value. So like -5 volts would be backwards. Let's do -4 volts. That'll be half the volts that are within the range. And then download, play. This is forward at negative volts, it's counterclockwise. If I do reverse at -4 volts and download that to the program and play, it's actually going clockwise. So I have like a double negative going on here. So I think when I program my robot, I'm just going to keep it always at forward and then just manipulate the voltage between negative and positive. If I do a voltage of 0, download that to the robot, what would you expect to happen? Voltage of 0, it's not moving at all. It's not sending any power to the motor. You can try stopping the program, try -1 volts, see if that's even enough voltage to get it going. And if I'm going forward at a -volts, I would expect to see counterclockwise rotation. Download and play. Yeah. -1 volts does get it going very slowly. And forward at +8 volts was the example I started with. Download and play. So now let's say if I wanted to use a controller to do this instead, I'm going to add a controller. So adding the device, go back to that to show that. Hit the little hardware icon up here. Looks like a smart motor port. Add device, add a controller, and then my toolbox will be populated with things that I can do with this controller. Now, in order to be able to read the controller over and over, I'm going to need to put in a forever loop, and then I'm going to assign this value to spin so that it will be checking for the controller value on a consistent basis. Instead of 8 volts, I'm going to put in a button on the controller. I'm going to use a joystick. The joystick axis 1 on the controller is left and right. So I'm going to use, say, axis 3 on the controller. That's this left joystick up and down. You can plug the controller into any port and it will automatically detect it. You don't have to assign the port number for the controller. I'm plugging into port 20, but you could plug it into port 21 on the side of the brain if you wanted to. All right, let's click the question mark up here and see what this gives me. So this block of a controller will give me a value of -100 to +100. So if I press this joystick all the way down, I get a value of -100. If I press this joystick axis 3 all the way up, I'll get a +100. And then right in the middle would be 0. And then I can choose any value in between by pressing a little further or a little less to its extremes. However, I need this to be between -8 and +8 volts. So I need to scale this value -100 to scale to -8 volts to +8 volts. I'm going to use that or do that by multiplying and dividing. So to scale to 8 volts, I'm going to say I want to do 8 times the percentage of this controller divided by 100. So if I wanted to go full speed forward, this axis would give me a value of 100, right? That's the full range of full up in the axis 3. And if I did 8 times 100, I would get 800, but that's way too big of a value to put into this spot that's expecting a value from -8 to +8. So I'm going to divide by 100 so that it would get it scaled back down to 8. So 8 times 100% full up on that joystick would give me 800 divided by 100 give me 8. And then if you check that over the different ranges, it checks out that Control Z, I have to grab this whole thing, grab this whole icon, and with the upper left side of this, I'm going to drop it into that box. You can see a highlight over the 8, and it'll fill in that box. So over the whole scale, I'll be able to scale this joystick axis of pressing the joystick all the way down to a -100, and I'll be able to get a -8 value out of this. And try that out. So download, play. I started my program, and I can see that if I just press it a little bit, this axis 3, the motor does spin slowly. If I go faster, it goes faster. So again, reading through this program, when the robot started, so whenever I start the program, it's going to check this command forever, as fast as it can process. It's going to spin the motor to 8 times the axis value, 3 on the controller, divided by 100, which should keep me in the range of -8 to +8 volts. And then it will go back and do it again. Just going to keep checking it as fast as the robot can process that. Wanted to get out of the program, I can press this red button. It's the power button and also the back button. Press stop. And now because I have a program pushed to my robot, I can go to programs and choose the program to run it. Exiting and press the back button and stop. And then also you could access that from your controller. I have the controller tethered right now with one of the smart cables. You use either the ports back here that the smart cable will click into, and then you could use any smart port on the robot. It's common to use port 21 off to the side. I've got it plugged into 20 right now. And I can go over to programs and then choose that directly from my controller and click run. And then I should be able to see that my robot's driving. So that's configuring a motor controller 55 using the VEXcode website. VEXcode code v5.vex.com. Code v5.vex.com. And then I won't have any of these tools to use, like spinning the motor or using the controller, until I've added the hardware. So adding a device within B.E.S.T Robotics, you could expect to use one controller. You can, within the V5 system, use 2 controllers, but that's not legal within the game of B.E.S.T Robotics. So one controller, you could expect to use up to 4 motor controller 55s. And then additionally, you would get servo motors, and they are within this 3-axis, 3-wire connector and servos. And you could choose one of 8 ports on the side of the brain. So those are the different devices that you could expect to use on a common B.E.S.T robot. Additionally, if you wanted to use sensors, they're also through the 3-wire port, and you could use a digital in for any digital sensor or the potentiometer. Potentiometer is the only analog sensor that gives you a value other than just 0 and 1. And all other sensors in the B.E.S.T Robotics kit are all digital in. You can use the limit switch whenever you're wiring up a limit switch, but it behaves basically the same as a digital in.